This slide is to give the example of the integral wind up. So we can see this is the error function. The error is quite large. It is between 0 to certain value of temperature, which is in degrees Celsius. So the error is in degrees Celsius. So over time, when we perform the control action, including the integral error, the integral function will total up the area under the graph of error here, and that will result the integral function. We can see here the thin line. So this is the integral control signal over time. And we can see the next one is the proportional control signal. This is the proportional control signal over time. As the error reduces, the proportional signal will also be reduced. But combining both P and I, the error is something like here, represented by blue, light blue color here. And finally, the actual control signal, which is limited to, let's say, 5 volt. So the value represented by the controller are far more than the maximum controller output. So the controller output will be saturated at 5 volt. So that is the issue related to the integral wind up.